This video will take you through the back of the net force examples. So examples 4 through 7 are on this. So work along and fill in your paper. But first we underline all the numbers and figure out what they are. 60 Newton object, so that's telling you the weight of the object. Meters per second squared measures acceleration. Pushed with a force of 101, so that's an applied force. Next we make our diagram. So somebody's pushing on this object. You're asked for coefficient of friction, so there must be a friction force, and it's accelerating. So we know there's a net force. Every diagram has weight. There must be a force that balances that. It's the normal force that's sitting on the table or something. The box pushes on the table pushes on the box. That's the normal force. Somebody's pushing it. I don't know if it's left or right. I always draw to the right. And then there's friction opposing motion, but that's shorter, so I have a net force. I write my equations from the diagram. The normal force equals the weight for this problem, and applied force minus the friction force equals the net force for this problem. Next, to make a plan. When I am done with this problem, I will have found mu. That is the last step of this problem. So I'm going to put it way over here. That's the last thing I'm going to do. So how am I going to do that? There's only one equation with coefficient of friction in it. That's the friction equation. Do I know the friction force? No. Here's what I know. Nope, I don't know the friction force. So before I get there, I have to find the friction force. I don't want to back up yet until I'm sure this is good. So I'm going to find the friction force. I'm trying to find mu. Do I know the normal? Yes, because in this problem, normal is the same as the weight, and I do know the weight. I'm just going to write myself a note so I remember that when I get there. Okay, how are we going to find the friction force? Well, we already used the friction equation. You can't use that again. So I need to look for another equation that has F in it. The equation from the diagram. Do I know the applied force? Yeah. I'm going to be looking for the friction force. Do I know the net force? No. So before I get here, I'm going to have to find the net force. Okay, so this equation will be okay when I get there. How am I going to find the net force? I already used this equation, so I can't use this. I'm going to use F equals ma. Remember, there's two ways you can use that. The one way is the net force causes the acceleration of the object, which is what I'm doing here. So I'm looking for the net force. Do I know the mass? No. So before I get here, I'm going to have to find mass. Before I move back, I should make sure this is good. I'm looking for net force. I'm going to find the mass. Do I know the acceleration? That's the acceleration of the object. When I use net force causes the acceleration of the object, yeah, I do know it. So that'll be the 12.4 when I get there. Come back here. How am I going to find mass? Well, the only equation with the m in it is the F equals ma, but I'm going to use it the other way this time. Where this time the force is going to be the pull of gravity, so this is acceleration due to gravity. The pull of gravity is weight. I know that. So we're ready to go forward. Pause the tape here and try it yourself. Do not just keep this playing and writing on your paper. Stop, try it yourself, and think. Weight, 9.8. Net forces cause the acceleration of the object. I just found mass. Okay, I hope you got that. Let's try example 5. First, we identify all the numbers. A 675 Newton object, that's telling you the weight of the object. Remember, if I'd say it was a 675 kilogram object, I'd be telling you the mass of the object. Meters per second squared measures acceleration, and that's mu. I just like to put it up there so it stands out, so I know this is what I know. This, and this. Next, I make my diagram. So once again, we're pushing on something, causing it to accelerate, and we know there's a friction force since we have a coefficient of friction. Got the pull of gravity, I've got weight down. The table or ground is supporting it up, and I know they're equal because it's not accelerating that way. I'm pushing it to the side, either side, and there's friction opposing the motion. So in this problem, normal force is the same as weight, and applied force minus the friction force is the net force. Now I know it seems like we use that equation all the time. We might as well write that on the board like it's a new equation. No. I swear there will be different diagrams. Your equations come from the diagram, so it's important to make a diagram. Alright, so what are we looking for? With what force must you push? We're looking for the applied force. So I will be done with this problem when I find the applied force. How do I do that? Well, the only equation that has applied force in it ever would be one for my diagram. So I'm using this equation for my diagram. So I'm looking for applied force. Do I know friction force? Nope. So I will have to find friction force before I get there. Okay, let's make sure this is good before I back up. I'm finding applied force. I'm going to find friction force somehow. Do I know net force? No. I'm going to have to find that also before I get there. How will I find the friction force? This has friction, but I already used that equation. So I'm going to use the friction equation. Okay. Do I know the coefficient of friction? Yeah. Do I know the normal force? In this problem, normal force is the same as the weight, so yeah, I do know it. I should write myself a note right here to remember that this is weight. How will I find the net force? F equals ma, where net forces cause the acceleration of the object. Do I know the mass? No. So before I get here, I'm going to have to find mass. Let's make sure this is good before I back up. Do I know the A to put here? Is it 9.8? No. Remember, 9.8 goes with weight. This is the net force. Net forces cause acceleration. So this will be the acceleration of the object. 35. How will I get mass? Well, the only equation with m is F equals ma. This time it's going to be 9.8 because I'm going to use weight. Weight, 9.8. I know the weight, so I'm ready to go forward. So pause the video here, try it yourself before you hit play. know I always say to use 3 sig figs, and I used 4 here, but it was just a 1. I mean, changing that to a 0 wouldn't have changed this along the way. Let's try example 6. Let's identify all the numbers. What is the coefficient of friction if 594 newtons gives this 83.7 kilogram object an acceleration of 4.25? This force gives the acceleration. Is that the weight? No, because they give me a mass here. They can't give me the weight and mass. That doesn't work out. This is not 9.8 times that. So that's one reason I know for sure that's not it. But what are they talking about? They're talking about pushing something with 594 newtons gives it an acceleration of this. So this is the applied force. Kilograms, of course, is mass. And meters per second squared is acceleration. Force diagram now. We always have weight down. They're asking for coefficient of friction, so it must be sitting on something, so I know I have a normal force. They're asking me what the applied force is, so I have an applied force. And friction opposes the motion, and it's accelerating, so I know it's smaller. Yep, same diagram again. So normal force equals weight. It won't always, but it does again. And applied force minus friction equals the net force. It won't always, but it does again in this problem. Now to make our plan. We will be done with this problem when we find the coefficient of friction. I know what I'm doing now. I'm not going to write find every time. But I do like to write at the top, so I know, when I get there, I remember what I'm trying to find. The only equation with mu in it is the friction equation. Do I know the friction force? No. So before I get there, I will have to find the friction force. I know in the video I start here first. Normally I'd look there first, but I know when I made this I looked here. So do I know the normal force? No. But the normal force is the same as the weight. Do I know the weight? No. So before I get here, I will find weight. I'll write myself a note that this is weight. So before I get there, I will have to find weight. Before I back up, I've got to make sure this is good. So I'll find weight. I'm looking for coefficient of friction. Do I know the friction force? Nope. So I have to find that before I get there also. Make sure one equation is good before you back up to the other one. Okay, so this equation will be good when I get there. How will I find weight? Well, I know mass. If I know mass, I can find weight. F equals ma. But this will be weight that I'm looking for. I know mass. And this is the pull of gravity. This is the acceleration due to gravity. Weight, 9.8. So that'll be good when I get here. How will I find the friction force? I already used the friction equation. I need another equation with friction force in it. Here. Equation from my diagram. Do I know the applied force? Yes. I'm going to find the friction force. Do I know the net force? Nope. So before I get there, I will have to find the net force. I already used this one. So the other way I can use net force is F equals ma. Where net forces cause the acceleration. So I'm looking for the net force. I know the mass. And net forces cause the acceleration. This is the acceleration. So I'm good. Go forward. Pause the tape. Try it yourself before you hit play again. Coefficient is 0.290. Remember, these are usually less than 1. I hope you got that. Last example. We'll identify our numbers. With what force must you lift to accelerate a 20 kilogram object 2.5 meters per second upward? So we have acceleration upward, we're going to need a net force upward. Finally, a new diagram. 20 kilograms measures mass, and 2.5 meters per second squared, that's the acceleration of the object. Let's make a diagram. Of course, we have the pull of gravity, weight down. Somebody's lifting this. Lifting force. Well, think of our 5 forces, but what would lifting be? That'd be an applied force. And it's accelerating upward, so my net force has to be upward. The applied force has to be bigger. Anything else? Nope. No strings, no ropes, no tension. It's not sitting on anything, it's being lifted, so there's no normal force. It's not rubbing against anything, so there's no friction. That's it. Just one equation. The applied force minus the weight is the net force. Okay, let's make our plan. With what force must you lift? So we're looking for the applied force. The only equation that ever has applied force in it is whatever you get from your diagram. So this, equation from my diagram. I'm looking for applied force. Do I know the weight? Nope. So before I get there, I'll have to find weight. Before I go any farther, let's make sure this is good. I'm looking for applied, I'm going to find weight. Do I know net force? No. So I also have to find net force before I get here. How do I find weight? I know mass, weight, 9.8. F equals ma. I'm looking for weight, that'll be the force. I know the mass, and I know when I use weight, the pull of gravity, I use 9.8, acceleration due to gravity. So that'll be good. How am I going to find net force? That's also F equals ma. I'm going to use it the other way, where net forces cause the acceleration of the object. So mass, I know. That's the mass of my object. Acceleration of the object, I know. 3 steps. It's a 3-stepper. Pause the video and try this yourself.